Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at packet forwarding. We'll be discussing packet forwarding decision process, end-to-end packet forwarding, and packet forwarding mechanisms. This episode is part of my series on switching, routing, and wireless essentials. I'm Kevin here at KevTechify. Let's get this adventure started. When a router gets in a layer 3 IP packet on its ingress port, the ingress once again is that port going in where traffic arrives going in, so this is the ingress. It will look at the destination IP address. So it'll pull out that destination IP address from the packet header, and it's going to look here at its routing table. It's going to go through and look at its routing entries and compare the prefix and the prefix length. So it's going to look at that network portion for an IP version 4 address. And we'll determine the network portion based upon the IP address and the subnet mask. You can determine that. Then once you have that, it'll go through and look for the longest match. It'll go through, and finally it'll find something and it'll match it out. It will send it out a port towards its destination. It'll send it out there. That router will do one of two things. If that destination IP address is on a directly connected network, we're going to just forward it right to that PC. So if it's on that directly connected network, we're just going to go ahead and forward it to that PC, to that server, to that printer, whatever that end device is, we're going to go ahead and forward it to that. Now, if that destination IP address is on a remote network, once again, I have to go through another router. What I'm going to do is I'm going to go ahead and just forward that packet to the next hop router. We're going to forward it to that next hop router, getting it one step closer to its destination. Then that router will go through this process again. If the situation does occur where it gets the destination IP address and it looks at the routing table, it looks at all its routes entries, and it doesn't match the first one, doesn't match the second one, doesn't match, it doesn't match any of the routes in that routing table. What's going to happen is we're just going to discard it. We're going to drop it at that point in time, because we don't know how to get to its destination. We don't know how to get to its final destination. If we had a gateway of last resort, that default route set, then we would forward it to that router, that default route here. We would forward it then. But if we don't have that defined, we don't know where to send it. And instead of keeping it cluttering up our RAM, cluttering up our processor, we just drop it at that point in time if we don't know where to send it. The primary responsibility of the packet forwarding function is to encapsulate packets in an appropriate frame type for the outgoing interface. Now, there are several examples we can use here for that, for a serial interface of the proper format, point-to-point, HLDC, or some other level 2 protocols. But to get that end-to-end packeted forwarding, that primary responsibility of the packet forwarding function is to encapsulate those packets. Looking at the different packet forwarding mechanisms, the more efficient that mechanism is to forward the packets, the faster those packets can reach its destination. Now, it may sound a little funny to say, yeah, you're going to save a couple milliseconds on forwarding those packets, but on a small network may not make a big difference. But on a larger network where you got thousands of users and thousands of end devices all sending all of this information, saving a couple milliseconds on each packet times all those packets going through your devices, that makes some great efficiencies on your network. That lets data get through there a lot faster. Now, routers, they support 3 different types of forwarding mechanisms: process switching, fast switching, and the Cisco Express forwarding. Process switching for packet forwarding mechanisms is an older mechanism. And when this packet comes in this device, or comes in the ingress interface, the interface where it comes in, it sends it to the control plane. This control plane is where the CPU is, where the RAM is. This is where all the processing and thinking is happening. The control plane looks at each frame, matches it to the routing destination, sends it to the egress interface that interface is going to go out of, and then forwards it on. It does that for each packet it gets in. Now, it's important to understand for this process switching, it will do that for each packet, even if it has a bunch of packets in a stream. If you're sending 1,000 packets there and it's all going to the same destination address, this process switching will look at each packet coming in, analyze it, go through the routing table, and then forward it out. Even if the next packet is the same destination, it'll go through this process every time. So it's repeating that process over and over and over. That's what process switching is. Fast switching, it's still considered an older packet forwarding mechanism, but it is an advance of the process switching, the older one. And what happens is when that first packet comes in the ingress interface, it looks at what we call this fast forward cache and says, is there an entry for the destination IP address in there? So we store destination IPs in here. If it's not, we send it up here to our control plane. Once again, the control plane that does all the thinking and processing, figures out, goes through the routing table and looks at each of the entry, find the longest match, then sends it out the port it's going on to. When it does that, it updates this forward cache. Now the second packet for that destination, that same destination, we look at the fast forward cache here, we see that the destination IP addresses match, and then we just forward it on right away. We don't have to process it. So it saves a little bit of time in that. And then the third and fourth and fifth and the 1,000th packet that you're sending all this big stream of data doesn't have to get processed by the CPU every time. The third mechanism is the Cisco Express Forwarding, or CEF is what a lot of people call that. Now, this is the default Cisco IOS packet forwarding mechanism. It contains what we call a forwarding information base and then an adjacency table. And what happens is it builds this table, and the table only changes when the network changes. It's not packet triggered. Packet triggered like the last forwarding mechanism. Every time the packet comes in, we go ahead and we look at the cache. If it's not in there, we build it and then we forward it on. After a while, it may get overwritten, and eventually you come back in another day, you send some information to that destination, it'll have to learn it again. Here, this table is built in RAM, and it stays there until there's a change to the networking. So once your network has converged, all the routes are known, all the networks are known to all the routing devices, it's converged, that FIB in the adjacency table, it never changes. It stays the same until it detects a change in the routing table. When there's a change in the routing table, it goes through a little bit of updating, convergence happens again, and then that table, it stays the same, and it always forwards it out. It was my pleasure to provide you with this wonderful episode on packet forwarding. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on switching, routing, and wireless essentials for the CCNA. Thank you so much for watching this episode on my series on switching, routing, and wireless essentials for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.